Thank you very much for attending my speech. Just a bit of a background why I would like to speak about how to put big data analytics in production, but maybe even more important, why do I see a difference? Well, not a clear difference, but maybe it's better to say that a marriage between what big data means in terms of IT infrastructure and setup and what big data analytics means and how these two have to go together to create value for the clients. So, as I was introduced, I'm coming from a background of being a statistician. So I'm in this industry of analytics for more than 12 years, so I have gone through many steps, starting from the classical analytics, being the witness of the BI and reporting era, and now for a few years this new fancy and the most sexy job, which is called a data scientist. And the best definition I heard about what is a data scientist. A data scientist is a data analyst who lives in San Francisco. So from this point of view, makes a lot of sense to become a data scientist. So a few years back, in a way, analyzing data and hosting and storing data were some kind of different things to deal with. Of course, there were the relational databases, even huge ones. There was for instance, the SQL, Oracle implementations for the big companies to store enormous quantity of data. And when it comes to producing insights, running analysis, doing predictions, forecasting budgets, analyzing the return on investments, making a linkage between the professionals you have in your company and the cost of them, a prediction of how much this human force will cost. So in simple words, all these were more or less predictive analysis. It was a gap. We had, and we still have, a lot of good softwares like SPSS. We have R, which is an open source. We have MATLAB. So many good and powerful technical solutions. But when it came to connecting to the data in real time, in lifetime, there was a gap. Now, the more we step into this big data era, these two components are becoming closer. And I now refer to the speech of my colleague from this morning from the Czech Republic, and I couldn't agree more that even if you are living in the era of big data, there are many companies who struggle a lot with their current small data, and it's a pain, and there is a market, a huge market out there to scale up and bring them into the era of big data. Just to give an example, one of my clients, of course I will not give the name, it's a medium small company who has hired a dedicated person, and it is called a big data specialist to deal with 300,000 rows of data. This is not big, right? But the perception is there. So my complex data or the data I do not understand should be big, right? So that's the perception. Okay, so there is a big problem with the big data. So if we think to the big companies which have budgets to invest in buying technology, in buying software, they all know that all the data of all types is stored and accessible somewhere in their business universe. But they all agree. Then there are great platforms to handle this data. We have on the market exceptional programmers to build apps, to build all kinds of software. There are super geeks, statisticians to explain you a lot of statistical modeling and predictive modeling. And still the companies are saying, so what? What's the gain for me in this? How all this combination of nice technologies, good professionals, can bring value for me, can produce something that I can sell or optimize my costs or make a better decision or hire better people or win a new niche in the market. So for the companies, these are the real and tangible things that they will be happy to invest in. And if the big data analytics is the solution, yes, they will pay for it. So the first thing that I see that needs to be addressed is the so what of the companies when it comes to presenting big data solutions to them. In simple words, to address this so what question of the companies is about three things. Play first with the small samples of very well selected data. Then move whatever you found in those data, whatever model you have built into that small data, move into their bigger data universe. And when I like to use this word data universe because looking historically at the investments of the companies did into data storage, we will find an entire spectrum of data storage, data warehouses, unstructured data, recently Hadoop clusters, so a combination of all kinds of data storage systems. So every company would like to see how this can be brought together, how you can make sense of all these data sources. And if you go to them just saying, oh, just throw on the window all your old data system and buy a new one because this is the good one, they will not listen to you. So how, from analyzing a small sample of data, you will integrate that finding into the bigger universe of data, and in the end, and here is where the value added comes, is to move the analytical processes you have developed into production. And production means to give analytical insights, like having a live prediction into a classical report, if you want, to the stakeholder who has to take decision, for instance, on the budget. So again, to summarize, three things: finding significance in small data, moving into the big data universe and looking for prediction power, and in the end, delivering production of the analytics and triggering proactive actions. So these are the things to be successful when you go into a client environment and start speaking about how you will analyze its data. This is what I have explained in brief, and on top and on bottom are the two main pillars. You have to have a very well connected data universe, having different components from classical structured data warehouses and ending maybe with Hadoop clusters, and to have a good analytical platform which is reliable and can connect to all of these different sources, combine the data, produce some models, and then move it into production. And I put a small explanation here what I mean by finding significance and finding and looking for predictive power. You might be in a position to choose some data, small data, and produce, let's say, a simple forecasting model, which will anticipate, will predict, let's say, the sales volume. In terms of the classical statistical analysis, it might be not so significant. So the power of that model might be not that high, but when you move into the big real data where you have extracted that that sample of data that you have built a model on, you will find that the predictions that are generated to that model are reliable enough, such as somebody to take decisions. This is more important than obtaining some very high statistical coefficient that will say that this model is super reliable. So that's what the stakeholders are looking for, predictive power. That's what I meant by this. If you have any questions on the road, just stop me and ask. That's absolutely fine. To be more tangible, my speech, I've chosen a recent project that I was working on, and it is a big data related project coming from the telecom industry. And I chose this example exactly because it is a combination between structured data and free text. It is about the name of the company is Telia Sonera from Sweden, and they have a problem to link the issues into the network, like clients being dissatisfied because of the quality of their signal, they don't have internet on their mobile, or any kind of trouble into their mobile telephones, and to the vendors, their vendors that are making maintenance on the physical devices which are producing or are the source of these troubles. And why this is an issue? Because there was one system recording all the troubles, and some operators was writing in free text that in some specific location there was a blah 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 with a free description of the problem, and there was a completely different system which was recording and issuing a ticket to solve the problem. So in a way they were aware about where, how often, and what is the problem in their network, but what was the cause and how it was solved and how to measure the efficiency of the vendors that are providing this service, it was not there. So that's the kind of insight that by looking into this big data setup, we can pull out and we can produce and we can bring value to that. Okay, so what you see here are, I always call this as the data exploration step. It's simple things. First is a Bayesian algorithm, which is a statistical one. The second is a joint table produced under the SQL platform. All this has by parentheses. In terms of technology, all these analyses have been done using Teradata Aster technology. So, what's the value in this data exploration phase? We took the free texts, and the first issue we had was that there were two languages out there. There were Swedish and English. So first step was to deduce how to separate these two languages and how to make text mining, text analysis, sentiment analysis to extract the most often words being associated with the troubles. And for that, we applied an algorithm. It is called the naive Bayes algorithm for detect the language. Okay, then in the second stage, we had to map the findings from the free texts, like the name of the vendors or the name of the issue, with the corresponding tickets that have been raised into another system to make the linkage between these two data sets. So applying a statistical algorithm into a subset of free texts and combining with another subset of data from structured data, which was recording with numbers, hour, so all structured data, we were able to produce a sort of algorithm to link these two data sources. Again, that was done on a subset of data, not on the entire big data they had. So it was just the exploration on how to extract meaning and how to link data sets. So that was the data exploration phase. Then it came the data discovery phase. So what you see here, this picture, it's the translation into the big data, so the sources of those two subsets, free text and ticketing system, and to replicate the entire algorithm into the big data. And here what you see, the main nodes are the type of issues, the type of errors, and the edges and the small points are the resolution tickets. How it was solved, what ticket is associated with, and so on. So by looking into such a picture, we saw there some red edge over there, which I had put on a bigger scale on the left hand, and we saw that, for instance, an error, an issue linked to the power outages is in most cases linked to a particular resolution ticket, which of course leads to a certain vendor who is providing this service for the mobile telephony company. What was the action triggered by this finding? So they decided that it makes sense for this type of issues in the network, when it comes and when they have high peaks of such troubles into their network, to support this vendor by adding additional support. They were not aware that in many cases, because of the lack of the bandwidth, a particular vendor who has to deal with power outages cannot solve in real time all the requests. So from there came a lot of dissatisfaction of the clients which have bad quality in their mobile service. So far we are still in the data discovery mode. We just discovered an issue by linking some free text with some ticket numbers. We still need to do something more. So what I was mentioning at the beginning of my speech, moving into production. So for that, the next step, and for this I will switch from the PowerPoint to a small application. We have built a sort of an app to monitor certain nodes of this network that were affected by this type of error. And we allow me to switch from the PowerPoint to the app. Okay, a few seconds. So we put this kind of analysis is called NPEF, and shows and is built for this particular type of error for a particular node into the network, and allows the operator which is monitoring the network to see, for instance, from a stable status, how probable is to move into a fairly high stable status, to go into a mid-level stable status, or to go to a high-risk status, in which case some action has to be triggered, some intervention is needed, but this kind of application is backed up with the analytical model that has been first discovered into the small sample data, then put into the big data and discover the true reason of the error, and in the end produce an application that can be used by the normal business analyst, operator of the client, and to take real-time actions when it comes to such issue. So I try to demonstrate to you that following these three, let's say simple steps, looking into a small sample data but relevant, producing a model that will have predictive power into the big data, and then move it into some app, some application which embed all this methodology into a real-time production mode, it can help a lot and produce value for the clients. This is what the clients will pay for. And this is the value of big data analytics combined with the strong big data IT setup into a company. Thank you. Open for discussion, questions.
You mentioned your problem with significant data, your sample data. Did you get relevant data? How difficult is it?
Well, you can. Here is a nuance. Significant data is one thing, significant model is a different thing. So in this case, we have chosen the right texts, the right free texts, which were describing issues in the network, and we took a subset of, in this case it was 1/3 of the data. So we applied that statistical principle that you will first build something on 1/3 of your data, and then you will validate on the rest of 2/3. So if you want to look into a big enough subset of data, you can just select randomly a subset of the data. But if you want to obtain a significant enough model based on some set of variables, then you will not have to stick to the classical statistical significance. So even a medium level reliable model built on a number of variables, it might turn to be powerful enough to produce reliable predictions when it is moved into the larger data set. So make the difference between significant subset of data and significant model built on a subset of data.
So basically you are selecting the data, not the client deliver you the data.
Yes. Yes, I select the data. Somehow this is the role of the data scientist to see if they have chosen enough data to produce something reliable. Yeah.
And that means you already analyzed their system.
Sorry, please repeat.
You already analyzed their system to get them to know what kind of data they have.
Yes, absolutely.
Thank you.
Another question.
Yeah. Please.
When you're going from small data to big data, do your model hold, or do you see some differences on the model? Can you share some experience on that?
There will always be a difference. So I'll give you a very classical example. We all know what a correlation means. Correlations, classical correlations functions only on small data. When you move into big data, all variables are correlated, and you are in a big danger to find wrong correlations. So that's why I made this difference between significance and predictive power. So you might start with a weak model built on a subset of data, but when you start running big amounts of data through that model, you might find that it is validated and can produce the right outputs. And of course, all these are validated, because the inflow of data which is coming will validate or not your prediction. So the simple answer, there is always a difference. Yes, please.
Hello, my name is Christy. I have a question. So I understand that you basically are selling analytics to companies.
Yes.
This is your service. How much time do you spend for a new domain? So how much time it takes for your company to assimilate enough domain knowledge to actually make sense of the data and start doing data science?
This is a very good question, and it's also a debate in our days. If you have to have domain knowledge, industry domain knowledge, or it's enough to be with the basic understanding, and then all the rest is about analytics. I usually spend time with consultants from the client. I would say that it is impossible to build any kind of analytical framework without being in direct connection with, on a day-to-day, sitting on the same table, talking directly with the expert from that industry. So to answer your question, it's a matter of a few days 1 week to run a workshop to exchange the understanding of the meaning of the data with the right professional from the client side, and then from that point forward it's a I might say purely data science exercise. Yes, please.
How do you select the subset of data? How do you know this is the good subset?
You don't know. You just don't know.
You don't.
The simple answer and honest answer.
Don't you have a control group?
Yes. So yes, you can apply any of the sampling techniques that we are used with from classical analytics. Like I mentioned, in this case, we've selected 2/3 of the 1/3 of the data. You can select other sampling methods that make sense for that particular data. But when you have in mind that in the end there is a huge big data set that you have to work with, even doing a random selection would probably be enough for the very first raw model. So we have to change completely, and here I make a parenthesis again, there is again a discussion if data science will replace statistics going forward. Because many of the classical approaches on the small data simply just not function on big data. So I tend to say, and this is not something that have been proven, but from my personal experience, that even a random selection large enough from a common sense point of view would be enough for the very first raw model. Then, when you go into production and you start feeding the models with a big data stream, you will observe if your model works or not. And then you come back and maybe then you will start thinking to a different way of selecting the data and subsets.
And another question, suppose I have a large graph database. How would I select samples from there?
Based on the linkage between nodes.
But there is no random data because there is hard linkage there. So I'm limited there. So that's the biggest problem the recommendation engines currently have. They cannot provide predictions correctly because the linkage is something that our human nature connects, and there is no niche there.
Maybe then you have to go with different kind of modeling, like a propensity scoring, to evaluate and to measure the human impact into the network.
Okay, thank you. We don't have much time, so thank you, Remus, for the presentation.